Hello and welcome to today's webinar. I'm Kevin Westerling, Chief Editor of Water Online. Thank you for joining us for this presentation on how to build faster, more accurate sewer and storm models. Our presenters are Nathan Gertz and Ryan Brown, both of whom are systems engineers at Innovyze. Together, they will walk through best practices using InfoWorks ICM, or Integrated Catchment Modeling, which provides hydraulic and hydrologic modeling results that are both quick and accurate, allowing for a better and faster resolution to flooding and overflows. Before we get going, let's briefly discuss technical information. If at any time during this event you experience technical problems, take a moment to refresh your browser and see if that resolves the issue. If your problem persists, please submit a question via the Q&A system and we will help you diagnose and resolve it. If you have a question for one of the presenters, please submit it through the Q&A system and we'll answer as many as we can at the end of the presentation. At this point, I'd like to turn it over to Nathan Gertz of Innovyze. Nathan, the floor is yours.
All right, thank you. I am going to begin sharing my screen. And there we go. So my screen should be up. Yeah, thank you. Nathan and Ryan from Innovyze. We are both systems engineers, so we work with our product management as well as talking with different utilities and consultants on understanding our various tools and helping equip engineers out in the field with the right solutions to save time. So this is our passion. We both have been using these tools and we do speak from some experience. Just kind of getting started with the content. You may have noticed that the title is suggesting that you can achieve model results that are faster and more accurate. Now, to the engineer minds out there, you might be immediately thinking, like, yeah, right, that's too good to be true. It's a trap. That's the compliments of the other presenter. Thanks for that, Ryan. But so we're going to talk through really three overarching themes using what has become both of our favorite modeling tool in this space. That is InfoWorks ICM. Innovyze has a number of tools that do sewer, storm, and flood modeling. But really what has emerged as our flagship product is InfoWorks ICM. I'd be happy to share any stories on that, but really it comes with like a 20 to 30 year history coming from a nonprofit from the UK, Wallingford Software, that emerged, and we merged with them, and it has become one of the largest modeling tools used around the world. It's maybe less common in the US, but it's very common in every major country. So that's the tool that we're going to be focusing on, and it does come in all sorts of shapes and sizes. So it might be a good fit for you. So really getting into it, the three things we're going to talk about is the database. That's what I'm gonna share on. It's not something that's exciting to many people, but I think the implications on what it can do for your workflows are actually very exciting. Ryan's going to talk about the engine. It uses a proprietary engine that is implicit and just generally very fast and robust. Ryan will get into some details on that. And then finally, doing the analyses, letting your results come to life and allowing you to drill into the actual insights that you need to get from your model, right? Just piles of time series data doesn't tell you much, but being able to bring life to the results and help you answer those questions can really turn a model into much more valuable insights. So let's get into modeling in a smart database. And I want to apologize to any viewers who have been attending our water talks lately. These are a couple slides I admit that I have used before. So if you have been watching, following some of our water talks, I apologize. A little bit of this is some slides that you may have already seen before. But let's talk about, so in a traditional modeling system, you might store your model copy, but you'll have a master copy of the model that's stored on a data server. So this is like from a municipality point of view. And let's say you're someone on the modeling team, let's say John, he pulls a copy of that model from the server and he's working on it to do a new loading scenario. And then let's say Susan, she also needs to do another separate project that's kind of closely tied to what John was doing. But John says, "Hey, I actually noticed a couple things that I fixed, and so you should use my version." So she pulls a copy from Model A. That's Model B. A couple days later, John decides to do an alternative approach of this new loading scenario. So he's looking at another kind of one-off spin. That's Model C. Susan decides to consider upsizing a pump. That's Model D. By this point, you're needing to wrestle through how do you merge the changes. Like if John noticed a few things that he had to correct, you want to pull those, but you don't want to sift through the things that he did that you don't want to have. I'm sure every modeler can relate to some of these headaches. And at the end of the day, you need to figure out how you archive things back to what is the master copy. And a year later, it can just be files all over the place, and it can sum up to be days wasted. It's actually very error prone when you have when you're trying to remember the different changes that have been made. And importantly, it actually discourages teamwork. In many cases, people will just want to kind of separate themselves from this whole model editing process because you'll know that you'll have to deal with data versioning and remembering what changes different people have made. And eventually you may need to start from scratch. So the alternative is what InfoWorks ICM uses is a service called a workgroup data server. So the model is on a central data server that's shared, but there's a software service that's sharing it with any user that opens it up. So let's say, when you open up your laptop and open up the model, it will pull a local copy so you can make edits locally and efficiently. And multiple people can both be editing the same model at the same time. Now, these are separate copies, but it's just whenever you click save, that checks in your changes, and it will notice if there are any conflicts. So if two people argue that if two people say the same pipe is different diameters, the software will recognize that, and it will pop up a conflict resolution box where someone will have to resolve it. And obviously that is very rare that people would argue about a pipe diameter. But with that, allowing multiple people to be working on the same model at the same time just really promotes collaboration. And among modeling teams, you have different, everybody has strengths and weaknesses, different perspectives. And so this allows you to have different insights, different points of views, fixing and cleaning and noticing problems in the data. And so the way how we actually facilitate collaboration is we have version history going back in time. So it stores every change that's made by every person pretty efficiently. So you can go back in time at any point in time. We had one utility that had been using the software with the a field mobile work order management system as well tied to it. And so they had many changes a day for many years to the database. And so I think they had like version 600,000 or 700,000 of their database. So it can actually store a pretty crazy history efficiently and feed that to you. So as you're working, you can actually do edit, undo, and redo, which sadly not many modeling software can do. The results can be shared. And the other way that we allow this collaboration so that your data actually gets better rather than diverging and getting worse is there's data flags on every piece of data. And this is optional. Admittedly, not everyone uses this. Some people like to just I don't care, I just want to get in and do a model. That's fine, but if you want, you can set up as many different data flags, so colors with labels that can indicate your confidence in each value of data. So this little GIF just shows blue are default values, orange are data from GIS, and then you can have like in this case, green has my initials, and red is where we have inferred data. So every stormwater and sewer system I've seen is there's going to be holes there, there's going to be gaps, missing elevations and things like that. To run a model, you need to have some value there, but so having inferred data flag allows you to fill in a value, but know that you do need to come back and correct it when you get a chance. And while you're calibrating, you'll know which parameters you have more uncertainty over. And so that's really helpful while you're calibrating, because you know where to go, what to change, what to adjust, and what is actually field verified data that thou shalt not touch, right? So this GIF just shows it can track as you make changes. So here I am making a change to an inferred value, that 24-inch diameter. And as I make the change, it just tracks my initials, so that when Ryan comes and opens this model, he can know that Nathan is the one to go to with questions if he's curious where that 32 inches came in. Okay, so a quick GIF to show this working out in the software. So we have a selected pipe on the map. As you select things, they become red in the profile, and here are its properties. And you can see in this profile, there's a lot of gaps in the data. This is not how a profile should look. You can see here are some of the data flags. And there's also inline validation. So it will flag as you're entering the data if the value is outside of acceptable bounds. Like if you have a missing invert elevation, it's not going to run the model with that. So it will tell you immediately where and what the problem is with an error message. So so this GIF is going to drag on this inference, and what's going to happen is it's going to fill in the gaps in data, and as it does it, it's going to apply that inferred data flag so that I know I can come back to it and fix these. And so you'll see that applied in the properties. So there's the inference. It fills in a magical profile, but you also then know any value that it did fill in, it is flagged, and so you can go back and correct it. And notice that it also does it for the head loss coefficients. And so ICM actually has built in an optional head loss engine where this pipe that was selected, it's coming from a 90-degree bend, but it is going straight out. So it actually detects the geometry on the map and applies a coefficient, head loss coefficient of 8 upstream, but a downstream coefficient of 1. And those numbers might seem high to you. It's built into the algorithm. It actually dynamically changes with the surcharge conditions. So an 8 is not necessarily an 8 times v squared over 2g. It's effectively less under most conditions. So so those are a couple features. And to summarize, what I covered is we have a central database. I didn't actually talk too much, but about pulling in data from GIS and other models, but you can synchronize data with GIS really powerfully. And as you import, it can also track those flags. So that flag, data flag tracking is built into all the imports. So as you're pulling in data from GIS, from SWIM models, HEC-RAS models, other ICM models, you can track where that data came from. Once it's in there, you can do the version control, the data flags. My favorite piece is having Sql Queries, which is really your power tool when working with data. And I think Ryan's going to mention that a little bit later. We've done Water Talk presentations on that. But you have a lot of tools for cleaning up and building up the data integrity, and you can have multiple people working with that. So the last piece is then time series data. So that is a feature called time series database. We store it in a little bit different format that's built for time series data. And so this can be tied directly to your rain gauges, your flow meters, radar rainfall. So we can pull NextRad radar files directly, as well as forecast data. We can bring in pump status. And so these can all be actually tied to your like data server where it's being stored live and have it directly connected to the model. And okay, really any time series data, you can have that tied in there. So just to show that process, traditionally or typically, what happens in most cases, you have sensors out in the field, you have a model database. How do we get these two together? Well, sensors usually will have some kind of sensor historian. Maybe your IT SCADA team has a data warehouse. Maybe this is behind a firewall, or maybe it's on the corporate side of the network, but it's the data is being stored some way, in some way. And usually engineers will have to request the data, and then you have to do a bunch of manual processing, and then you manually import it into the model database, and you connect it to the model. And that works, but it's pretty slow, and you'll do it for one event, but then the next time there's a large rainfall event, you have to repeat the whole process. And so it's pretty slow. And I've seen an emerging trend throughout the country where radar data is being more commonly used because of just the spatial resolution is much better than a rain gauge network in many cases. And so I've seen some consultants or other companies trying to find ways to get this to go into manual processing and into event files. You can do it in ICM, but it's pretty time consuming. So the alternative is you can actually tie directly to the time series database. And so as a modeler, once this is set up, when a new storm event occurs, I just open up ICM and I say update, and it will pull yesterday's data because it's tied directly to the SCADA telemetry system. And then I run the model with that date range, and it can pull the radar rainfall. You can see the rainfall intensities move across the network. And also anywhere that you have a flow meter, it can auto compare how your model is comparing to flow meters. It could also do boundary conditions, upstream, downstream, inflows, pump status feeds, etc. I've seen even people using the groundwater infiltration model tied with forecast groundwater models, forcing the model. So there's some really cool stuff that people have done with this, because this is actually the stepping stone to do a real-time forecast model, which is definitely where we see the industry headed. So all right, one last gift from me. This is just a view of a sewer network with a handful of different sensors on the network. And so we can have symbols where the sensors are. And when you graph a pipe with the sensor, it will know to pull in the measured data so you can see how the model's comparing to measured. And this GIF is showing as you zoom in, it will continue to integrate the volume. So it will actually kind of show you the volumes as you zoom into different time periods. And you can create these scatter charts that some engineers like to do. So just lastly, just kind of one more time, you can have like data labels where as you're choosing different time steps, so you can see the flows from the flow meters. You could have a script that would spit out root mean squared error differences for all of your different model results, and so on. So there's a lot of power in just finally connecting these two things, because a sensor is a large investment, a calibrated model is a large investment. It just makes sense to bring the two together for that synergy. So that's the database. Multi-user version controlled data flags and direct integration with other sources like GIS and time series data. So I'm going to hand it over to Ryan to talk about the engine. All right, Ryan, you want to kind of share your screen?
So that should be up for everyone now. So like Nathan was saying, kind of the second pillar for this is the ICM simulation engine. So just kind of briefly going over what are the things that really make ICM faster. Nathan mentioned that it's a proprietary scheme that goes into being able to use larger time steps essentially, and with that of course you're able to run simulations much faster and get reliable results still. Parallel processing, being able to queue up these simulations, being able to run multiple simulations using just one license and being able to utilize the full CPU that's going on there. And then probably my favorite piece is, being able to accelerate the 2D simulations using the graphics card. And then lastly, being able to run things remotely. Often, especially maybe like bigger organizations or something like that, have specialized servers that they set up with some high-powered performance equipment, different kinds of hardware specially fitted for modeling purposes. So just kind of taking a deeper dive on each one of those different points. This is an infographic. There's a lot of information on this, and really my biggest point with it is it's different. Over on the top corner here is where a little description of the equations, the St. Bernard equations being solved in ICM, and to put it really succinctly, the easiest way to think about it is that it's converging on volume rather than converging on flow, like a lot of the different swim methods or like the swim method uses. So, a lot of people ask us here, what are these differences? What kind of, what difference is it really going to make? So, relatively recently, we did add in the swim engine for people to be able to, utilize all those great things about the workgroup database, and then also be able to kind of compare and contrast different things. So as you see on the bottom here, I've run both of these simulations. So that top one, I actually started the swim simulation first, and then started the ICM simulation, and it's ended much faster. As you can see, we're still waiting on the swim engine, even though these are the same network, same parameters and things were used in it. And then if we go and look at the results, you can see the ones for the swim. It's not a terrible continuity error, but at the same time, if we go to the ICM one, you can see a lot of these that same kind of convergence error indication, they're all 0. So, you're still getting a very accurate, probably arguably more accurate result using the ICM engine. So just kind of in summary, the time difference between these two, 15 seconds versus around 41 seconds. And that might not seem a lot, but as you get bigger and bigger, this is a relatively small model. I think it's like 900 nodes or something like that, and it's fully 1D. As you start to get into these different, more complicated models, bigger models, and especially the 2D simulations, and I've got some more comparisons for that. You can see some really tremendous differences. One last thing, just to point out, how do these different solutions compare? So looking at the max water level for each one of those simulations that I just ran and comparing it, so you can see, based on our R-squared value and our slope of approximately 1, we get pretty similar results between the two, just as a kind of simple comparison there. Of course, it's not going to be the same just because it's solving things, and you're going to have some outliers and things like that, but for the most part, very similar results. And it's also probably worth noting, just because it's the swim method and it's maybe more universally used or something like that, doesn't necessarily mean it's more accurate. So some of the other comparisons that we've done, with the 2D and how much the GPUs can really save you time. I'm not going to go through all this, but you can see the HECRAS runs taking significantly longer than some of these ICM runs down at the bottom. Being able to use the GPUs is certainly beneficial, and that's something that a lot of other modeling softwares out there aren't able to offer. So doing some other kind of comparisons, just what's the difference between just using CPU versus GPU? How much can really accelerate? So we did some testing a couple of years ago, and ran the same exact model with 1.6 million elements, 2D elements, and just using the CPU. It takes about an hour. And we're able to reduce that by about 12 times by using a simple GPU card. And these things aren't fancy; they aren't expensive. I looked up this one, and I think you can get it for like $300. So it's not like these things, cost a bunch more money, and you need to make a lot of investment there. The graphics card that you have on your laptop or desktop computer can generally be used. The one thing that it does need is to be CUDA enabled, which I know a lot of the NVIDIA cards are, but pretty similar results too, just as another example for a model that's about twice the size, still achieving that pretty significant improvement in the runtimes. So just being able to, as an example, just being able to run things on a remote simulation, you can of course have all of this installed on your local computer and being able to have the user interface and the engine all on that computer, but you can also kind of farm this off to have kind of a central space where, if you're in a bigger organization, being able to store all your results and model information there, being able to have some maybe dedicated servers with that engine on it, being able to run simulations on there. So, having it set up like this, you're able to have just, the UI in certain places, and then being able to use some of these specialized servers or dedicated servers with some high-powered equipment or something like that, being able to run those simulations much faster. So, you can see, as you get more in depth and more ingrained with ICM, being able to really expand the level that you're able to leverage your resources. So just as an example, when you go to run a simulation, you can pick different machines that are connected to yours, depending on the availability, and then also if you know one as the level of computing power that you need. So just moving on to results analysis and what we can do here. So one of the big things is, being able to use different themes simply by just, dragging on different themes, being able to see different kinds of information, whether it's the, overflows or flooding in certain areas, just being able to quickly pull those onto the map and see those things pretty quickly. They can also, be pretty nice for presenting all the information and things like that, being able to quickly do that. I should also point out, these are part of that workgroup database. And so these can be used across any model. You don't have to, you can come up with kind of a library of different themes and being able to use them across your entire organization, depending on, what you need or what your project is. Another great one that Nathan kind of mentioned briefly before are Sql queries. And as you can maybe see in the example when it gets pulled up, that these can be really simple, but they can also be really complicated, and being able to put together some more information and leverage the power in these that much more, but at the same time they can be really simple and still give you a lot of good information. So the types of results you can, as you can see in the example, you can select capacity problems pretty quickly and easily. You can summarize results in a grid format over a certain window time. Look at outflows, pull up reports, different sorts of things like that. There's also the capability of being able to use direct scripting. So this is an example of some code, and you can program those into different user buttons up at the top, and being able to write these different kinds of programs to be able to really pull things in and then export them as well pretty quickly. So having something set up so that you can quickly update your model or pull those results out depending on what you need. I know, and I guess we'll get to more details on it in a minute, but we do run our series Water Talks at Innovyze, and I know next week Nathan is talking with, I guess he's a consultant, about this direct scripting and being able to leverage some of the power there. So if you're interested in more of that, I'd encourage you to sign up for that. Also viewing results. So this is one of our 3D views and looking at river system and the flooding that's occurring over time. So you can get some really detailed looks at things, and just, I mean, it looks pretty. Like I think it looks great. You can even see some of the piers from the bridge and some of the roadway deck and stuff like that in the terrain. You can also, of course, pull up results looking at the profile of your system. You can look at the plan view of it and be able to see those different mesh elements and things as they flood, and then also being able to pull up different graphs of flows and rainfall intensities. And it should be noticed, you can see some of the colors and things changing. That's associated with the theme. So as you run your simulation or run the results from your simulation, those will change and can kind of alert you. I should note that, that theme is carried throughout. So even the profile is showing that same kind of theme and better understanding for what you're seeing in your model results. Of course, you can, overlay the radar data, like Nathan was talking about with the TSDB, being able to see the rainfall intensities on different cells that are going over your catchment, and then also, of course, the profile view, and all of those things are linked together. So, as you can, drag the time period and stuff like that to be able to, hone in on certain times and results and things like that. And then also, we have an add-on called Risk Master, and being able to put together damage costs and things like that within your system. Being able to see some of those results can be really powerful in determining different the flood strategies and management scenarios. Being able to understand really how much risk does your system have, and what kinds of impacts are you causing because of, or not because of, fixing a problem or capacity. So as I mentioned, we at Innovyze do run a series called Water Talks that kind of is set up a lot like this, in terms of just being a webinar and really being an effort to engage with other professionals in the space and being able to do that kind of thing. So if you're interested in this and more, like I mentioned, the one next week I think is going to be really, really neat, with the direct scripting and the consultant we have coming in to talk about that. So I don't know if you wanted to add anything else, Nathan.
Yeah, we've just been having a growing number of people attending our water talks, and that has been fun. We kind of just get into some of the nerdy topics, and it's been fun. But yeah, the guy next week with scripting, he is actually a modeler and a programmer, and so he has a number of high level scripts on GitHub. So he's going to be covering some different free scripts that you can get access to. And then the following 3 weeks actually is we're interviewing users around the world. So I think the first one is some ICM users in Australia talking about how they've used it on projects. The following week, I'm going to be kind of interviewing with a guy in Texas with Trinity River Authority on how he used InfoWorks ICM on a COVID-19 tracing project within sewer systems. And then the third week is ICM usage up in Scotland, I believe. Scottish Water is, I believe, if I'm not mistaken. But yeah, just getting some different case studies out there, seeing how the platform's used around the world, because it is unique in that aspect.
Yeah, and that's a good point about some of the libraries for scripting information and stuff like that. Being able to, because you have some Sql queries and I would guess some Ruby scripts and things like that on your GitHub, don't you, Nathan?
Yeah, and I'm always happy to share them with anyone. So if I think our email might be on the next slide, but yeah, if you're ever interested in any of that, feel free to reach out to me or Ryan.
Yeah, so we are at the time for questions. I just know with like the scripting, personally, I feel like it's overwhelming. I definitely don't have a background in computer programming or and I'm not quite as smart as Nathan is, so he's got a real knack for it. Yeah, if you guys have any questions, please drop them in the chat. It looks like we're getting to some. One of the top ones is can it import, export to and from XP swim models? So I guess I'll start off answering that, and the answer is kind of. At Innovyze in general, we've kind of centralized on the EPA swim file, so you would have to export it out from XP swim and then into that .inp file, and then import that into an ICM network. You can directly import it into a swim network in ICM, but that would be, of course, a swim network. So.
Yeah. Just to add on that, so yeah, we can import directly into the Swim 5 network, and so the features that you would lose would be the 2D integration that is just unique to XP Swim. So you'd have to redo 2D within ICM just because it uses a different framework, and also some other add-on things in XP Swim like using SCS hydrology, because that is not really natively supported within EPA Swim 5. You would import and you'd get all of the physical information, but some of those hydrology parameters you have to export and import separately with tables. Good question. Actually, on that, so yeah, there are some other models that we do have direct imports to, like HEC-RAS geometry files, EPA Swim, of course, InfoSwim we can import directly from, as well as I was seeing some emails just last night on importing from Mike Urban models. So yeah, we have a handful of different ways to pull data.
Okay, guys, do you want me to commandeer the Q&A and just shoot them at you?
Yeah. I guess I forgot you were here.
Okay. No problem. It happens all the time. No, great job presenting. We do have a decent amount of time left in the hour, so I encourage the audience to keep the questions flowing. I'll grab this one for you. Is there a way to set up the central data server?
Yes. Yeah, so the central data server is actually not licensed. So you can, actually anyone can download it from our website, and it's just a light installer on. Actually, I guess backing up, I might not understand what you mean by central data server, but you could run it on a virtual machine or a server within your network, just so long as you have network access to talk to it through TCP/IP. I think it uses a specific port. So like if there are firewalls, we can work with your IT team to open up a certain port so that modelers with out on laptops would be able to pull connect to data on a central data server.
Okay, and what is the programming language used in direct scripting?
Yeah, the InfoWorks uses Ruby scripting. We do often get feedback, especially in North America, that Python would be more helpful. I can agree. We have shared that with product management, but at the moment, Ruby is what is supported, and I can at least say from my side, not being familiar with Ruby, it's really just a matter of getting some of the example scripts that have been put together. And once you see the syntax, it's actually pretty straightforward to read, and you can pretty much just copy other examples of what has been done, and you change some of the method names. But yeah, so we have some an introductory guide and different things like that to get started. But yes, it is in Ruby.
Okay, this goes way back to my intro, but could you please explain how your product is faster and more efficient in calculating RTK values?
Yeah, so I know there's a popular feature with InfoSwim and the RDII analyst and being able to automatically calculate those RTK values, but that's not a part of InfoWorks ICM. There would still be a calibration process needed to come up with those.
Okay.
Yeah, like calculating the RTK time series. That in itself is a pretty a straightforward concatenation of hydrographs. So that's straightforward. But assuming that you mean calibrating the RTK values, that is a tool that is not currently in ICM, and there have been a number of requests to add it. We have possible plans of actually incorporating that into a cloud service so that it's shared among all models. So I think that's where a tool like that would be headed. So yeah, you can likely expect that in the future.
Gotcha. How is the dual drainage system handled in InfoWorks, especially for multiple major systems?
Yeah, Ryan, do you want to tackle that one?
I would just say it's inherent to the engine. I know there are other kinds of software out there that use different kinds of methods, like a Muskingum Kunge method or something like that, where looped systems and dual drainage doesn't really work. I guess I don't know if you're maybe talking about like diverging, because I know some you have to like specify how much flow is going to one pipe versus another. That's just not the case with ICM. You can hook up as many pipes as you want to a node and have flow exiting that, and depending on the downstream boundary conditions of each of those pipes, or the capacity of the pipes, or the elevation of the pipes, it'll be able to handle that for sure.
Yeah, and on that note, we have seen just like a trend that more and more people are using 2D modeling, and so some of those 1D dual drainage is becoming less common, and you'll just have an underground system overlaid with a 2D mesh on top.
That is a good point, and honestly, that's probably one of the reasons I really like ICM, because it can handle those 2D simulations much faster. So you're not having to put overland weir connections and stuff like that. You can just use 2D, and it doesn't matter because it's running pretty quickly anyway. So
okay, great. During the presentation, it was mentioned that there was a trend towards real-time system forecasting. What is your experience with attempting real-time modeling, and what are some of the challenges that need to be overcome? For example, is it a processing power issue, or are there any other thoughts you might have on that topic?
Yeah, great question. I've been previously I worked in the Innovyze implementation team, helping implement models, and Innovyze has actually been doing real-time modeling for about 20 years. Initially, it was called FloodWorks, and there are some systems like across the whole river system in Belgium that's a forecasting model that we support, but ICM has an add-on called ICM Live that takes that time series database that I mentioned, and it connects it to a server service that will basically automate the whole thing. So on like a 15-minute or 30-minute basis, whatever time of concentration is of interest for your system, it will pull raw data. It can do the data scrubbing, and then it runs the simulation. And then after the simulation, it will then trigger an alert engine to sift through the results and the time series data for any events that you care about. So for example, you could deploy it as a flood forecast system, where it would then look at really high water levels, close to manhole flooding or actual instances of flooding. And so you can deploy it like that. And in terms of processing power and run times, of course, many large cities, when you run a model of like New York City, that can take a long time. So the way we overcome that is that ICM Live can be deployed at multiple different scales, and namely multiple different smaller subsheds. So for example, Thames Water, which covers services like the entire London metro area, a really large population. They've been running ICM Live since the 2010 Olympics or 2012, and the way they achieve it is they have separate models for different watersheds, and they are running, and each simulation can pick up where the previous one left off. So it's always stitching together the antecedent conditions, soil moisture, and forecasting effectively from where it was before. And then just having the power to run simulations remotely and scale up your resources on demand. Yeah, there's a lot to that question. I don't want to ramble for too long, but.
And I guess one other important thing to overcome processing power, skeletonizing the model, and then as things happen within the system, you can set up, you can deploy it so it runs that skeletonized model, and then as you get maybe certain warnings, it'll run those smaller subsets of models too. So you're not having to run your fully complicated model all the time.
Excellent. Thank you, guys. Are there tips and tricks to get the model to initialize on its own while maintaining accurate results? How often are 1D and 2D models found not able to self-initialize when running simulations?
Yeah, that's yeah, I have. Yeah, Ryan, do you want to take that one?
Yeah, just briefly. Yes, definitely. Sometimes there are definitely situations where it won't self-initialize. There is a process that you can stop the self-initialization, but normally you run into problems and it'll crash or something like that. My biggest advice is, make sure that things are that things make sense. You can't have, I've seen problems with pipes dropping into the bottom of a river, but that's not really what would be happening in real life. And just little things like that. Steep slopes are, usually a problem in situations. I do know that, and then also running the model dry, we are adding in a finite volume solution for the 1D calculation. So you can actually run the model dry, which might help in some situations.
Yeah, I'm pretty excited about that feature. Of course, one definite thing to call out is we do have a support team globally, and we do get questions on this kind of stuff. So, absolutely, if you're an ICM user, just send us an email and have our engineers look into your model and diagnose it if there are any problems, and we can hopefully help you get squared away.
Right, and furthermore, for you guys, live Q&As can be tricky, so I'm throwing a lot of stuff at you. You can always get back to all of these users post-webinar, so just so you know. Okay, there's a couple questions about the EPA SWIM models and integrating it. I think you touched on it, but specific to SWIM 5, are there any issues with integrating that into InfoWorks?
Yeah. I'll take this one. So we did set up so that you can use a SWIM 5 engine within ICM, and if that's what you want to use, you can import it, and you will get the same results. Our engine team actually has about 150 different SWIM models that are auto-tested. I'm not sure if it's on a nightly basis, but they have, the DevOps team has scripts that auto-test these different models and make sure that results are matching. Specifically, getting into the weeds, we are using our engine team has our own copy of the SWIM engine, and we always will stay up to date with the latest. So right now we're on SWIM 5.0. 5.1.015, And as new versions come out, we're going to update. And so this I have has been important to some communities where they want to maintain their model, but they also want to be able to share the model seamlessly with other sub-communities or contractors. And so if that is the case, then perhaps just maintaining your model in a swim format is the way to go, and you can then still leverage the ICM database, remote servers, the themes, Sql queries, all of the different data cleanup tools. And so, yeah, there's a lot of benefits for that.
Okay, great. How can we stop creating a new simulation for every new version of the model? Can we just update it in the simulation window and rerun the simulation?
Yes, yeah, there is. So I forget which version it was a few versions back, but there is a checkbox on the run where you can say allow reruns with a new version. And so the workflow is you'd have your run and you'd have your network, and then you can make changes. You just commit your network, and then on the run you say update to the latest, and then when you click run, it will replace the old run results with the new results from the new version. So that kind of does effectively prevent that clutter from getting created in your database. So that is an option. Just kind of look for that checkbox. I'm not sure if that came out in version 9.0, but it should have been, I think, a couple of years ago.
Yeah, and I guess just to add on to that, I know from personal experience, like it can be a little frustrating having, because certain elements and things like that within ICM like turn to a read-only if you use it in a simulation or something like that. But it's really goes back to this whole idea with data integrity and understanding where your model is and where it came from and what kind of information is in there. The whole like work group database idea of being able to go back to previous versions and the undos and redos and those types of things.
Okay, excellent. So how can we create a theme in ICM? Does that make sense?
Yeah. Yeah, it is pretty straightforward. Once you have a model open, you right click and go to properties and themes. I suppose one of us could. Ryan, are you still sharing your screen?
Yeah, I am. I can.
Yeah. You just right click, open up that themes window, and you can make any changes you want. Turn off layers, set a layer to be based on a certain data field in the database, and then you just tell it to save. So it is a pretty straightforward process, and that would be covered in the training as well as
and you
tutorials.
can add new things and things like that. And then once you do all that, it's just a matter of coming over here and having a new theme. So whatever is saved within your network at that point, then it'll go into that theme.
Okay. Are there plans to add explicit features such as nodes or link types for green infrastructure /LID as opposed to applying SUDS or SUDS controls to subcatchments or similar?
Yeah, good question. So within like the swim modeling world, we're used to applying LIDs within subcatchments. But ICM, you can use that approach. It's SUDS or LIDs on subcatchments, but you can also incorporate green infrastructure within the 1D network itself. So on your links, so like you could have, like if you wanted to model like a grass swale or some kind of, something like that, you can set the link from a solution model of full to permeable. And you can actually model, the permeable flow through different links, and you can apply infiltration at nodes and so on. So some of those features can be incorporated in the 1D, and I have also heard of people modeling green infrastructure in the 2D domain using rainfall on the mesh and using things like you'd have a number of polygons, from GIS that you would then import into roughness zones, as well as maybe mesh zones where you sink it into the ground a little bit so that water will pond there. Any other comments, Ryan?
Yeah, I mean, if there's, I mean, I guess it's maybe not exactly what you're asking, but if it's more design work and things like that, we do have another product, Info Drainage, that it does a pretty good job of being able to design some of those LID. And I think relatively soon we'll have an import plan to be able to bring those models into ICM fairly seamlessly. So.
Okay. Couple more questions on specific features. Can you add contour labels to the ground surface?
Yeah. Yes.
Okay.
Is it, I mean, I don't know if it's worth showing or
right.
whatever, but it's within the properties and themes menu, just like I was showing for the creating a theme earlier.
Yeah, I think they're just happy that you can. So
yeah,
they can get trained up on that. How about is there or will there be a way to crop ground models for more localized project specific 2D models?
I'm not sure if
could be a follow-up qualifier.
It might be. I don't know if you're talking about like mesh manipulation or being able to do some of the things you might be able to do within ArcGIS, like cutting out certain parts of a model. The closest thing that we would have to any kind of mesh manipulation would be mesh zones or mesh level zones, where you can specify, like if you wanted to maybe grade in like a ditch or something like that, you could use a mesh level zone to achieve that. Or if you have buildings that aren't reflected in your terrain, you can add mesh level zones and add on some 10-foot height or something like that to be able to effectively have those within your mesh.
Great. Okay. Let's see if we can get one or two more before we wrap up. Are users typically updating ICM versions as they are published and rerunning current models in the new versions?
Yeah, that does I think kind of depend maybe on the organization. I know some communities under consent decree might be tied to a specific version of ICM, but in any case that you're not enforced to use a certain version, then we do of course always recommend the latest version. I do feel like when I encounter people in support or other things, I feel like most users are usually maybe just like just one version behind in general from my experience.
Okay. So what interface is available to integrate field sensors data from MHs for real time? I'm unfamiliar with MHs, but you probably know.
Yeah. So field sensors at manholes. Yep. So once you have a time series database, and I should add that is an add-on feature to ICM. So it's not in the base of ICM. You do have to buy the ICM suite, which I do believe. Don't quote me on this, but I believe we just got. I think Innovyze is offering that add-on at a reduced price this first half of this year, because we do want to see more people using that tool. But once you have that, it's all configured in a table. You can add sensors on the map like any manhole. You just add a point on the map. But really, what I do in projects when I've set up models with 80, 100, a couple hundred sensors, I just actually set it all up in an Excel table, and you can just paste it right into ICM, and then everything just works. So it's really just a mapping of a sensor ID to a model object, and what does it do to that model object. So it's pretty straightforward to go.
Awesome. Well, you know what? Unless you have anything else to add, that does just about wrap us up on time. You guys good?
Yeah, just real quick, there is one question that kind of just says, leads with, where could you go to learn more? And we just released an Innovyze Learning Center. It's from our website. And this is where we are starting to upload a lot of web tutorials and training modules. And we are in the process of growing out the content. It's new this year. There's not a ton out there, but because there's not a ton out there at the moment, it's free. So, check out our website, and you can check that out, and always reach out if there's something else that you're looking for. And we do expect to. We have a lot of teams working to build out that online training content at the moment.
And I'll just add that I appreciate everyone coming and listening to us today, and great questions, and appreciate you guys' time.
Perfect.
Yeah, thank you, everyone.
Yeah, thank you guys, Nathan and Ryan, both of you, for your insight and expertise. Excellent presentation. As a reminder to the audience, we did log all of your questions, including those we didn't get to today, and we'll pass them along to the presenters and to Innovyze for potential follow-up. You will also receive an email in the coming days with the link to the full presentation. So with that, thanks very much for listening, and please enjoy the rest of your day.